So in today's workshop, we shall progress with the following agenda. We will start with the brief company introduction followed by introduction to seismic analysis. Then we shall learn different ways to perform seismic analysis on structure. Additionally, we will learn joint weight method and dynamic analysis using response spectrum method. And we'll be defining the seismic definitions, generating the seismic parameters. After that, it will be followed by a question and answer session. Request you all participants to kindly write the questions in answer box. Also, we shall be providing with certificates to all the successful completion of all 4 workshops, ending with the vote of thanks. So I would request all the attendees to write your questions in chat box so that I can answer them in the end. So Capricorn Technologies, we have like legacy of over 3 decades now. Capricorn has played a significant role in the country's computer-aided design adoption, and today we are concentrating on information modeling to address the start to finish design and construction difficulties faced by the building and infrastructure industries. We deliver the finest solutions, methods, and procedures to enhance your productivity and reduce your project risk. Our team of more than 250 plus designers based in all the major cities have constantly provided outstanding value, adoption, support, and services to optimize the true potential of more than 20,000 plus customers. Capricorn Technologies is now a Win0 company. On April 6, 2022, we became a global company with a footprint and impact globally. We have recently merged with the 4 international companies. First is US CAD from US, second Cadline from the UK, and Capricorn from India, and ATP Technologies from Australia. So Win0 is dedicated to educating its users about how the technology they employ now can assist them in moving towards net zero in the future and creating a better, sustainable society and greener future. Win0 is known for its inclusive culture of putting people first and passionately resolving customer difficulties. So this was all about us. Now moving on to today's session, which is seismic analysis. Seismic analysis is basically earthquake loads. These type of loads cause movement of the foundation of the structure. So earthquake forces are internal forces that developed on the structure because of ground movements. So there are different zones and all these zones are well defined in our code book, which is for seismic analysis, which is IS 1893 2016. Why 2016? Because TAD has now introduced the latest code book, and we should follow that only, and I'll be hosting or conducting this session totally on that code book only, with the latest code book, which is IS 1893 2016. And likewise, I'll also show you the parameters on which our calculations will be based on. So these are some criteria, like this is for the seismic zone that I have taken from the earthquake load only. Just to be more accurate, yeah, this is 1893 part 1 2016 code book, and based on these parameters only, we'll be defining the seismic definition on the structures. And so let's start, and I'll directly switch to my software. So just give me a moment to share my software screen. I hope my screen is visible. Kindly confirm.
Yes, it's visible.
Okay. So for today's session, I have created say G+6 story building, and on this building, actually, for the ones who are attending this session for the first time, in the first two workshops, I have already covered the basic part, which is assigning the loads and creating the loads, creating the geometry. So to view that work, previous sessions, you can go to our YouTube channel as well. All the recordings are available there. So today I'll be directly switching to the definitions part. So I have already defined these loads. First is this dead load. Member load is nothing but the dead load. So self weight of the structure I've applied. I've applied the wall load. So these are the different wall loads for the different floor to floor height. And these are the dead load. For an example only, I have kept the load as same, but I know with your live projects, it might not be the case. So I have kept the load cases same. This is for the live load. So all the basic loads I have applied. And now moving on to the first method, which is joint weight method. So what I'll do is, first I will assign the supports. Like I've already assigned the fixed supports, but now I'll assign the pin supports, because for the joint weight method, we need to calculate the weight which is coming on each node and beam junction. So to do that, I'll go to supports. I'll click on view and I'll select the left view, and say I'll select all the columns. To select all the columns, I've just pressed the select ribbon tab, and from the beam section, I'll click on parallel and I'll select parallel to y-axis. And now I'll go to view and I'll select the selected objects. Now moving on to create pin supports. I have clicked on supports, and after clicking on create, I'll just click on this pin support. I'll add this. Now I'll click on this pin support option and I'll add the pin supports to all the node and beam junction above the foundation level. I'll click on assign and yes. See, all the pin supports have been assigned. Now moving on to the how we will calculate the joint weights. So to do that, what I'll do is, first I'll create a load combination which will be combining all these three loads in one. So I'll click on load case detail. I'll create a load combination by clicking on define combination. Say I want to keep the load number as 100 and I'll write the name as dead load plus 0.25 of live load. And why I have taken this, because as per our Indian standard code, it has been written that if the live load or the imposed load is greater than 5 or equal to 5, equal to 5, then we have to assign the 50% of the live load. And if less than that, then we have to assign the 25% of the live load. So I'm taking this 0.25 of live load. So I'll, in the same way that in the way that we have written our combination, it is very important to take all these load cases in that manner only. So first dead loads and then live load. And here I will change the factor, which is 0.25. I'll click on add. Now I'll just click on close. This load combination has been created. And now what I'll do is, I'll just click on analysis first. And here I will add the command, which is of perform analysis. Perform analysis and close. Now I'll just simply run my structure. Now with 0 errors and 0 warnings, moving forward, I'll click on this post processing to see the support reaction table. For the results, we go to post processing. So I'll click on post processing, and from here I'll just choose a combination that we have created that we'll be using for joint weights. Either I can just click on this table, and with the right click on the mouse, I can click on support reaction table. Or what I can do is from here, layout option, in node results, I'll click on reactions. This is our support reaction table. Suppose I'll just click on the support reaction table. I'll click on copy. I'll open my Excel sheet and paste this result over there. I'll paste these results for the one more time. Instead of this load combination, what we have to do is we have to write here weight. Otherwise, it will show an error in the stat editor file when you will try to run the analysis. And for the joint weight, we only need the vertical forces. So I'm just keeping this F5 forces, and rest of the forces, I'll just delete them. So now before pasting this in editor file, we need to define our seismic definition. So to do that, what I'll do is I'll just open this file. Again, I'll click on this analytical model. Now I'll just go to utilities tab in the command file, or say stat editor file. I'll click on the support first. Now we don't need to have this pin supports option on. So with the comment option, I'll hide it. And I have actually already created the earthquake and X and earthquake Z load type cases. I'll explain it one more time how we will create these earthquake load cases. Just one thing need to keep in mind is we need to define these earthquake load cases before any other load case in order to reduce any errors. So these two load cases should be should be the priority. Now the question comes is where we have to define or where we have to paste those joint weights. So I'll just save this. Now we will create our seismic definition. In the loading part, click this definitions. From seismic definition, click on this, click on add, select the IS code. Either you can manually put the values here or just click on generate option here. Select the parameters, say I'll select Delhi. Accordingly, all the zones, importance factor, response reduction factor will be changed as per the selection of our, say I want to design it for say building with special moment resisting frames. So it is 5, and all other buildings, say I'll select residential buildings. So it's 1.2 as per IS 1893 2016. Say I'll say medium soil. I'm designing for the medium soil, and structure type RCMRF buildings. Sorry. Okay, damping ratio 5% generate. So all those changes will be applied there here, and now click on add. Now click on close. After defining this, I'll again go to my command file. First save the file. Now I'll directly click on this. Now just cut it from here and right here, because support should be together, and after that suppose we need to define our seismic definitions. Now after this seismic definition, you have to press an enter and write here joint weight, and below this you have to paste your joint weights. Just copy this, and paste it in the command file like this. And after that, just save the file, close. File is being processing. Now, if you will see over here, when you will click on this definition in seismic definitions, Under this zone, you'll see all your joint weights. Now, after doing this, you have to define the seismic load command. You have only created the earthquake load. What you have to do is you have to also assign these loads in X direction. So just click on this load case. Just remember, you cannot define earthquake load command uh, before defining the seismic definition. So first you need to define the seismic definition. Only then you can define the seismic command. So just click on the seismic loads option over here, next direction, add this vector, click on close, and now repeat the process for the Z direction. Select the Z direction, factor 1, close. So we have added this, and this is our joint weights. Now, either I can just show you how to, like, we'll just simply run this. So it is showing 0 errors. So like I'll also show you how to like define the load combinations. Like we have created the earthquake loads as well. To define more combinations, what you can do is, because there are two type of combinations basically. One is for serviceability load cases, which is used for foundation designs, basically the unfactor load combinations, and one is ultimate load combinations that we use for beam column designs to check the beam and column designs. So just click on this load case detail as you have, as the it will be like we'll create the load combination in the same way that we have created the load combination. Either you can generate like auto load combinations, just have to select the highest code and it will accordingly define your combinations, or you can say you want to keep the starting number as 101. Click on generate loads, so all the load combinations will be created. Or you can do is define combination. I'll not create much combinations. Just for an example, I'll create two load combinations for each, one for ultimate load combinations and second for serviceability. So first we'll create, say, 1.5 factor with 1.5 factor of dead load plus live load. So how we will select the load cases? First we will select the dead load. Now the live load, and there's a factor of 1.5. So over here in the factor box, we will write 1.5 as a factor. I'll click on add. Yes. So this is my 101 combination added. I'll create one more with earthquake definition. First I'll say 102 and name as 1.2 with a factor of 1.2 dead load plus live load in positive earthquake X direction. So first I'll select all the dead loads, then live load, and then my earthquake load with a factor of 1.2, 1.2, 1.2, 1.2, and 1.2. Add. वैसे like you don't have to like create these combinations again and again in the new projects. You can use your editor file. You can do the cut and copy paste method as well. This is just to give you the clarity how we can create the combinations. So now moving on to serviceability load cases, which are unfactored load cases. So I want to give the load combination as 201. And first I'll create dead load plus live load. So dead load plus live load, click on add. Now 202 and say dead load plus 0.9 of live load plus 0.8 of earthquake X. So this 0.9 is the reduction factor like reducing factor, which is also defined in the code book. Like as soon as your like structure goes with more and more storage, you can use this factor if you want to. Dead load, live load. Sorry, I forgot to add member load, then dead load, and then live load, and then earthquake. So live load is our load case number 5. Here I have to write 0.9 as factor and here 0.8 as factor in earthquake X. I'll click on add. So how we will, create or copy paste or load combination using start editor file. So I'll click on command file and I'll select this load combination. Suppose I want to create it for in the negative X direction also, like in negative earthquake X. Copy, I'll paste. Here I'll write negative and here I'll write negative. So this is how you can use your set editor file as well. Similarly, say copy, paste. Sorry, I forgot to change this load combination number. Here it will be 103. Instead of positive, write negative. Here also negative. And here you can also, like, if you want to define this, these are the like ultimate load combinations. So you can write the heading here, ultimate load combination, and you can comment this so that no errors are shown. Here you can say servicity load combination, and same way you can add the comment. This comment means these are hidden now, and yeah, just save the file. And now we will define some design parameters. Click on design, click on the concrete option. I'll be using IS456. I'll define some of the parameters like FI main, which is main steel, say 500,000 in kilonewton per meter square. And let's define the concrete strength, say 25,000 in kilonewton per meter square. Yeah, that's all for this. And I'll add the command of design beam, design column. I'm adding this commands because as of now, it will not show any result for any beam or column because we haven't designed it. So in order to design it, like in order to get the reinforcement details as well, you need to go to the design option and need to define the parameters. Say FY main, I want to keep the same steel in whole structure. So I'll assign it to the view, and similarly for FC 25,000. For design beam, I'll go to select. I'll select parallel to Y and I'll inverse my selection because I want to assign design to beam. And I'll say assign to selected beams. Now I want to assign and like design the columns. I'll select beam parallel to Y and assign to selected beams. Yes. So after completing this, like I have shown you how to define seismic definitions and how to create seismic load or how to define the seismic load, how to create or how to why we will assign the pin joints and joint weight method. So I'll just run this and I'll go to analysis and design. I'll just run this analysis. After completing the analysis, So when I'll just double click on this column, it will also show us the results now. I'll click on this concrete design. These are the area of steel required, percentage, bar sizes. Similarly, for the beams, these are the details we're getting. We are getting 3 of 10 dia steel in the starting point of the column, of the beam, and in the end we are getting the similar kind of reinforcement. Like right now I haven't defined more parameters, and like I've kept the structure very simple with similar kind of beam sizes and column sizes. But likewise, if you'll just change the sizes and everything, the results will be totally different. So this was our first method to like how we will define our seismic analysis using joint weight method. And if you want to see your earthquake load cases are like applying or not, see now these all are applying similarly in the z direction. And if you're like it will be also reacting in the negative direction, so we have already created the load combination for that. So accordingly it will be acting in the z direction and in the negative directions as well, as you can see. Now moving on to our second method, which is dynamic analysis method. I'll just like switch to another structure to define the seismic definitions, and by using response spectrum method. So like I have the same structure with all the same loadings and like everything. Earthquake load have already been created, member loads have already been assigned. So the only and the major difference is in this we have to like match the base share. And how we will do it, let's see. First we will define our seismic definition. Why we need to define for seismic definition? Because suppose I've already created this earthquake X load case. So when I'll click on this response spectra, remember this, while using response spectra method, you need to define it under response spectra, and while using joint weight method, you need to define it under seismic loads. See, even if I click on seismic loads, it will say seismic definition is required in order to assign a seismic load. Similarly in this also. So first we will define a seismic definition. I'll click on this. I'll click on add. In the similar way, we'll define our seismic definition. I'll click on generate. I'll choose the city as Delhi. All other buildings as residential, medium soil. Just I'll write somewhere the values so that I remember while doing this response spectra, and why I am writing these values will also like I'll also tell you this. Why I have used a reduction factor as 5 and importance factor as 1.2, medium soil, and dumping ratio as 5. Yeah. I'll just click on generate, add, close, close. After this, what we will do is similar way, the way in which we have defined or like pasted or joint weight, we have to repeat the same process as well over here. Like I'll go to supports, I'll click on create, I'll add pin joints, I'll select I'll select all the columns, view to selected objects, I'll select the left view, and I'll assign the pin supports. After doing this, actually, this is the same structure, so there'll be no difference in the joint weight. So I won't repeat this process again. Instead, I'll just click on this command file. I'll click on save. I'll hide all the pin supports. Now under this, I will say joint weight. I'll again paste this weight, but the difference is now we have to paste this weight in all three directions. Like in previous method, we have only pasted in Fy, but in this method, we have to paste it in all three directions, which is X, Y, and Z. Like we will take the values of Fy vertical forces only, but we'll paste it in Fx also and in Fz also, like same values of Fx. Say I'll write here Fx and I will say I'll copy all these two rows. I'll paste it here. I'll again paste it here. Instead of Fx, now I'll write here Fy and drag it till down. Here I'll write Fz. Like we have to consider the load in all three directions while defining our response spectrum method. After doing this, copy all these weights, copy, go to your command file and paste it over here. After doing this, like we have pasted the weights in all three directions, click save, close. Now after doing this, go to loading tab. Here now define your response spectra command. Click on response spectra. Here select your code, combination method HCQC, subsoil medium, like we have selected while defining the seismic definitions. In X direction, here X is nothing but Z by 2 multiplied by I by R. Z is our zone, I is our importance factor, and R is our response reduction factor. Here we have taken the zone as 0.24, which will divide it by 2 and multiplied by I is our 1.2 and R is 5. So after calculating this, we'll get, just give me a moment to calculate all this. Yeah. So after this, we'll get 0.288, 0.0288. And I'll keep the acceleration factor as 1, like add. Similarly, define the spectrum command here also. Use the code as 1893 CQC, soil as medium, and Z will remain same, and scale as 1, and close. First, I'll go to command file. I think I have pasted. First, I will just close my previous file. Because of that, I have just pasted somewhere else only. Sorry for that. Instead of here, we have to define the joint weight in all three directions. So I'll just I'll define the joint weight here. Say joint loads. And now I will paste my all this. Now I'll paste it over here. Yes. Like first you have to paste your joint weight under the definition command. And after that, under the earthquake command, you have to paste these weights as joint load in all three directions. And earthquake Z will automatically take these joint loads from above only. So I'll just save it. I'll click on close. See, joint loads have been added. Now I'll just analyze my structure. There is one error, no issue. We'll see. I'll go to command file. Okay. I haven't added perform analysis command. And also I haven't created the load combination because I haven't repeated the same process. So I'll just add the analysis command. I'll go to analysis, define command, add, and close. I'll run the analysis. So I'll click on view output file. Here you will see peak story share. Just click on this. First, we'll see for X direction. This is for the X direction. And we have to like keep in mind this cutoff mode, like 6 modes start calculates automatically, but we have to define cutoff mode shape factor on the numbers, like all the sum in X and sum in Z direction till it reaches 90%. Like Z is already reaching 90%, but for some X we have to define cutoff mode shape. First, we'll do that. What we'll do is we'll go to utilities, we'll go to command file. Above this define 1893 command, we will write cut off mode shape, say 15. I'll click on save. And say I'll also copy paste the say load combinations. So just give me a moment. So this was my original structure which I'm working in. I have just opened a new structure so that I can copy paste my load combinations. So I'll just click on this load case type 1 load combinations. Actually, there are load combinations over here. So I'll open my another file. Just allow me a moment. Okay. So I'll go to utilities. I'll just let's just I'll just check once more time. Yeah. So I'll just run and analyze. Click on view output file. Click on this big story share. Okay. So as you can see, we only require 7 cutoff mode shape, and because in 7 cutoff mode shape both x and z directions are getting 91% of results. So I'll just write down my so this is a warning which is coming. Bayesian calculated using empirical formula, like according to this code it should be multiplied with, so I'll just write down the factor which is 1.3345 for the x direction. And now for the z direction, the factor is coming out to be 1.4987. So basically we need to match this factor for both x and z direction, which should come 1.00, like 3 decimal places should be 0 at least. I'll just close this. I'll go to loading. In load case detail, where we have defined our seismic, response vector command, just double tap on that. Here I will multiply the factor which Stan gave me after calculating, which was 1.3345. So I'll just open the calculator. 0.0288 multiplied with 1.3345 comes out to be 0.038. I'll write 0.038. I'll modify it. Yes. Close. Similarly for z direction. It was 0.0288. Factor was 1.4987, which is 0.043. Modify, close. Again, I'll run the analysis. I'll click on view output file. Now let's see. Now it is okay, 1.0114. And for z direction, it is 1.0038. So one more time we have to multiply this factor. So similar in the same way we have to do this and till it comes out to 1.00, like 3 decimal places. So in this we have to match the base share, and start will automatically provide you with the SA by G factor, which is used for the time period. Like if I may show you, this time period for x direction is coming out to be 0.74884, and SA by G is 1.816. Like all your tedious manual calculations have been reduced. Instead of calculating the time period first and then calculating the SA by G factor, you just need to do the following procedure that I have just shown you, and it will automatically give you all the results. This was about seismic analysis and the like using first static analysis method and second is response spectrum method. So so if you have like any questions uh, regarding any of the method, please write it down on the chat box. I'll answer each and every question. And in the next workshop, we'll be covering, I'll be covering RCDC, which is Advanced Concrete Design. And in that, we'll be see each and everything in detail, how we will design foundations, slabs, beams, and columns using Advanced Concrete Design, which is nothing but RCDC. So I hope to see you all in our next workshop also. So as of now, if you have any doubts, please feel free to write in the chat box. I'll try to answer each and every question. I request all the participants to write your questions in the chat box or in the question and answer panel so that I can answer your question regarding this or any other topic that you want me to cover. I'll wait for next 5 minutes more for the question and answer round. I'll request you all to feel free to reach out to me on the number shown on the screen, or you can write a mail to me on dipali.arora@capricorn.com if you want to discuss anything regarding any query or troubleshoots or workshop. I'll arrange it for one. We can have one-on-one session also. Feel free to contact us or reach out to us. So I'll just wind up the session now. Thank you so much for joining, everyone.